Hello everyone, and welcome to this edition of our video newsletter. I'm your host, Jeff Perry. For nearly 30 years now, system designers have been able to choose FPGAs with core processing algorithms implemented in the digital fabric, instead of the more expensive ASIC CPUs. FPGAs include high logic densities and extensive I/O capability, making them ideal for a multitude of technically demanding applications for displays, communications infrastructure, and other electronics such as medical, automotive, and test and measurement devices. But when planning a system around any FPGA, one of the biggest challenges that designers can face is power. There are always multiple loads to drive, and your design will likely involve more than just one single power supply. There are FPGAs in the market today that have 9, 10, or more different loads on them, and there may be 5 or 6 different voltages involved in the design. What you need to know is, how can this design process be made easier? Well, to do just that, National Semiconductor is bringing you the WEBENCH FPGA Power Architect online design tool. The FPGA Power Architect tool is a breakthrough design tool that lets you simply input all of your voltage and current requirements, configure key specifications, and the tool will essentially design the entire system for you. Let's look at an example of a typically challenging system, a board that has 9 different loads on it. It's oriented around an FPGA right here, but it has a lot of other elements to deal with, like flash, SD-RAM, it has PLL, motor control, and IOs, and so you end up with 9 different loads and 5 different voltages. This gets complicated because not only are you going to have to run all these designs, you got to figure out how to connect all these up together and determine the architecture of the power tree. Let me show you how the WEBENCH FPGA Power Architect tool works. Here's what you see as you first go into the tool. For step 1 here, what you do is simply enter in your input voltage. For our demonstration, I will enter 22 to 26 volts. Step 2, you configure your loads by pressing the FPGA Load Assist button. What you get then is a listing of all the latest FPGA families from Xilinx, Altera, and other major manufacturers, and these lists are being continually updated. For each one of these FPGAs, we've documented the power requirements for all the different loads, the core, the IOs, and anything else that it needs, including transceivers and auxiliary loads. And what you can do is go in and just select one. Let's say you want this one, pick it, it pops up a dialog, and you've got all the loads pre-configured for you. Just set the desired voltages, then you click the Add button, and the tool will add in all the loads necessary. For each one of these loads, you get a level of detail that includes the load current, maximum output ripple that the load can tolerate, if it needs a filter, if it needs a separate supply, and also whether it needs a soft start or some sort of sequencing involved with it. Okay, so once you've done that, what's next is the actual architecture of the power supply system. So one option here is to drop it down to an intermediate rail of 12 volts, and from that 12 volt rail, come down to the point of load, controllers, and power supplies. Another option would be to go to a 5 volt intermediate rail or no intermediate rail at all. WebBench shows you multiple architectures side by side. Within one architecture, each one of these power supplies here may have 50 different possible regulator options. So what the tool does is automatically pick the ideal top choice for each one of the supplies. It does this based on your inputs to the optimizer knob for high efficiency, small footprint, or low BOM cost. Once we do that, we present the results in the visualizer graph so you can see how the best options compare. If you click on any of the bubbles in the graph or lines in the table, it will show you the selected architecture. The x-axis of this graph shows you the efficiency, and the y-axis shows the footprint. The bubble size, or the diameter of these circles, represents the cost of the design. The smaller those circles are, the lower the cost. And as you can see here, you got results in the lower left with a small footprint, but poor efficiency. And as you go up into the upper right area, you get to designs with high efficiency, but with a large footprint. It's up to you to choose the best solution for your needs. So we've made it easy for you to determine what is the best system power supply architecture for your needs. Remember, we're not talking about just one power supply, we're talking about the whole system. So in our demonstration here, the numbers really get magnified. After you're done with that, you click on the View Project Details button, which shows you more information about your project. From there, you click on Create Project Designs, and it will create the entire project for you. And at this point, you can do simulations, you can change components at the individual component level, and do everything that the WebBench environment allows you to do. WEBENCH FPGA Power Architect gives you unprecedented power to not just do one design, not just do a couple of designs, but you can look at a whole variety of different architectures using a pre-configured set of loads just for your FPGA. And do this all literally within a couple of minutes, and you can design a whole system-level power supply. So there you have it, the WebBench FPGA Power Architect online design tool from National Semiconductor, helping to make your FPGA design process easier so you can define it today and assemble it tomorrow. To get more information on these offerings, you can click on the links within the newsletter or visit us at national.com/FPGA_architect. That's all for this edition of our video newsletter. Thanks for watching. We'll see you again next time.